Alright, hi everyone, welcome to my YouTube channel City of Electrons. So in this video we are going to be talking about short three-phase line. Funny enough, this video is going to be short, hopefully. So the thing is this, the calculations we'll make for a short line, for a short single phase line, okay, is the same for a short three-phase line. Just that we'll make the calculation for one line is the same for the rest. Okay, so we'll calculate as if we are given a problem to solve with three-phase line, short three-phase line. We are going to resolve it and solve for one line. Like, assume we are solving for one line, and then when we get our solution, we bring it back to three-phase line. See, this one I'm trying to talk about. But first, bear this in mind, that we have delta connection and star connection. It's also known as Y connection, star or Y connection. Okay, star. Let me just put connection there. Connection. Okay. So these two. Then we also have the combination of both, which is star delta connection. Okay, now let me do this. For delta connection, I want you to think of it as if you are thinking of parallel connection, like a parallel network. Just think of it like that. I'm saying this because the formulas look like that. Okay, so IRP. What do I mean by IRP, or what do we mean by IRP? We mean that the current in the receiving end per phase, current per phase. Maybe you may have a different notation, okay, whichever notation you can have, but the point is, this is the current per phase. So it's as if this is the current, not as if, this is the current of calculation for one line, for a single line. This is the connection for a single line. So when we have this IR as the receiving end, current in the receiving end, we are giving that in the equation, or we have to solve that. We are going to take this receiving end current and we are going to divide it by the square root of 3. Okay, I think I should use my pen in this case. Okay, so in the case of that delta connection, I said think of it as if you are thinking of parallel network. So the current, receiving end current per phase equals the receiving end current you have divided by the square root of 3. Okay, experimental value. Okay, square root of 3. Now, what we are saying is this: instead of calculating with the receiving end current, which is what we have for the three-phase line, which is this, you will have to break this three-phase, the receiving end current, into one line. So one line, the current in the receiving end for one line is equal to the current in the receiving end divided by the square root of 3. This is what we mean. Now this is for a delta connection. Then the voltage for a delta connection, for one line, okay, that's what we mean by per phase, for one line is the same as the current, as the voltage for the 3 lines. This is one of the reasons why I say just think of it like parallel network, because in a parallel network the voltage is the same, okay, but the currents it depends on the branches, okay, out of a node. The current reduces, okay. So I'll be clear with that. Then for a star connection, think of it like a series network. For a star connection, think of it like a series. And you know, in a series network, the current is the same all through. Okay, that means the current per phase, receiving end current per phase, is the same as the receiving end current for the 3 lines. Okay, so the receiving end current for the 3 lines is the same as the receiving end current for 1 line. But for the voltage is now what we have as the voltage of the receiving end divided by the square root of 3. So it's just like the opposite of the delta connection. However, for the power, it's just to divide it by 3. So that is the power, let me put it this way, power per phase is the total power divided by 3. That's the total power divided by 3 lines to get the power for 1 line. So this is 1 line, this is 3 line, divided by 3 to give you 1 line. This is 1 line, this for 3 lines, divided by cube root of 3. This will now equals 1 line. This for 1 line, and this equals 3 lines. That's for delta. Also this guy applies. For 3 lines, the power for a particular line, power for 1 line equals power for 3 lines divided by 3. That's for power. Okay, and then this, of course. All right, so this is just what you have to bear in mind in terms of 3-phase short line and 3-phase line. Okay, so we're going to make use of these formulas also later on. There will be plenty. Okay, yeah. So if you have any question, you can leave it in the comment section. Just comment anyhow, whichever one, even if it's a question, contribution, anything. And like, share, subscribe. Click on notification bell after you subscribe, so you get to see videos I post on time. Yeah, man. Okay, thanks a lot for watching. Bye for now.